Welcome back to the deep dive. Today we are undertaking a pretty critical mission. It's one a lot of you have asked for, and it really requires absolute focus.
It does.
We know you're staring down the Agentforce Specialist Certification exam, and it's not a test of just general familiarity. It's a test of precision, of nuance.
That's absolutely right. I mean, this deep dive is going to be hyper-focused. We're not really interested in the general concepts you can find in any Trailhead module.
Right.
We've gone through and meticulously pulled out 65 of the most critical, often missed subjects, the things that come directly from the core material. These are the facts that make the difference between passing and, well, needing a retake.
Think of this as your accelerated study track. We're drilling right into Agentforce architecture, the specific mechanics of Prompt Builder, some critical data cloud integration points.
Yeah, the security requirements, the non-negotiable ones.
Exactly. And the deployment best practices that, so commonly fail when they hit production. Our entire focus here is giving you that precise knowledge edge you need to pass.
Our mission is simple. We want to help you understand not just what the Agentforce components are, but the architectural how and the deployment why behind every single one. If you can explain, for example, why a search index needs an update or why a flow runs in system mode, you've pretty much won.
Okay, let's unpack this enormous subject. We'll start right at the core. We're going straight into section 1. The agent's brain core architecture, reasoning, and intelligence.
Let's do it.
So we're starting with that foundational layer.
Sure.
When an AI agent needs to do something that requires an external tool like, checking an inventory system or retrieving a specific document, how does it dynamically know what tools are even available?
And how to talk to them, right?
Yeah, how to talk to them without having some hard-coded script.
Right, and that sophisticated capability is managed by something called the Model Context Protocol, or MCP.
MCP, the dynamic connector. What does dynamic really mean here? Why is that so important compared to, say, a traditional API gateway setup?
The dynamic part is the key architectural differentiator. And it's a major exam concept.
Okay.
In a traditional setup, you'd have to pre-map every single possible API call the agent might need. It's static, it's rigid, and it just becomes unmanageable as you add more tools.
It doesn't scale.
It doesn't scale. MCP just flips that on its head. It lets the AI agents or models dynamically discover, select, and invoke APIs or tools at runtime.
So the agent, in the middle of a conversation with a user, can essentially just ping a central registry and say, hey, the user needs to classify this document. What tools do I have available for that?
Exactly. That's what MCP facilitates. It's that dynamic service discovery and integration. The agent doesn't need to be programmed with a specific endpoint or the syntax beforehand.
Wow.
It just queries the MCP server, gets a list of capabilities, and then chooses the most appropriate one based on its reasoning engine and the user's intent in that very moment.
Can you give us a concrete example of that? When does that dynamic selection really matter?
Sure. Imagine you have a big organization, hundreds of microservices. One handles document classification, another manages pricing, a third runs legal compliance checks.
A typical enterprise setup.
Right. So if a legal assistant agent gets a new contract and the user says, I need an immediate risk classification, the agent uses MCP to instantly find the right document classification API, the specific one for risk analysis, without relying on some brittle, predefined workflow.
Wow.
That modularity, that runtime flexibility, that's what the exam really focuses on.
That dynamic capability is certainly impressive. Now, once the agent has, established what it can do through MCP, it still needs to figure out what the user is trying to do.
Yeah.
This brings us to the reasoning engine's logic. How does Agentforce actually classify what a user types in?
So the reasoning engine is the decision maker. It classifies the user's input into a defined topic. And it relies primarily on two really important fields that you as the specialist configure, the topic name and the classification description.
I would guess the topic name, something like product returns, is the most important part since it's so concise. Is that right?
Actually, and this is a key point, while the topic name is the concise identifier and it's critical for logging and all that, the classification description is arguably the most crucial piece of input for the LLM.
Why is that?
Because the description provides the natural language context. It explains what the topic is about, what kind of user queries fall into this bucket, and what the goal is. The engine analyzes the user's input against both of those fields to get a really nuanced classification.
So if I'm building a refunds topic, my classification description shouldn't just be handles refund queries.
No, absolutely not.
It needs to be much richer. Something like, this topic handles requests for monetary return initiated by authenticated customers who are dissatisfied with a recent purchase or service.
Precisely. That level of detail is exactly what allows the LLM to accurately map a user's complex sentence like, "My new widget arrived broken and I want my money back," to the correct topic. The quality of that description directly impacts accuracy.
And what if the user asks about something completely unrelated? Say the agent is trained for HR issues, and the user starts asking about the history of quantum physics.
That's where the failsafe comes in. If the user query is clearly out of bounds, if the reasoning engine finds that no defined topic sufficiently matches the input, it has to handle it safely.
Yeah.
It defaults to an off-topic classification.
Wouldn't it be more, helpful for the agent to try and guess the closest topic? Why is defaulting to off-topic so important for a robust design?
It's all about safety and trust. If the agent tried to force a fit, it might trigger an action, maybe a complex flow based on a guess that's just fundamentally wrong.
Right, a bad guess could be disastrous.
Exactly. By defaulting to off-topic, the agent handles those unmatched requests gracefully. It makes sure the agent gives a predefined, non-committal response, which prevents hallucination or accidentally triggering some sensitive business process. That graceful failure is critical for the certification.
That covers the classification. The what? Now let's get into the execution, the do. This is where a lot of implementations seem to fall down. The agent correctly identifies the topic, let's say warranty claim, but it invokes the wrong action, like basic status check, instead of submit full claim.
A classic problem.
So what's the primary lever a specialist uses to fix that kind of execution error?
The fix is almost always found in refining the action instructions. This is the most crucial configuration piece for action execution. These instructions are the detailed internal rulebook that guides the reasoning engine on when and how to use a specific action within a topic that's already been classified.
So if the topic is correct, the issue isn't the classification itself. It's the selection based on contextual nuance.
You've got it. The instructions tell the agent something like, only use the submit full claim action if the user mentions new incident and provides a serial number. If the instruction is vague, like use this action for claims, the LLM might just pick it whenever the word claim appears.
Even if the user is just asking for a definition.
Exactly. Vague instructions lead directly to false selection. Precision here is just non-negotiable. They are the primary driver of execution for any custom action.
Let's follow that failure path one step further. So the agent classifies the topic, selects the right action, but then the action itself fails. Maybe an external system is down, or the data retrieval step comes up empty. What should the end user see?
This is a point of frequent confusion. If the agent can't understand a request or retrieve information, it uses a pre-configured fallback message.
Why not just show a technical error code, or have the LLM try to politely rephrase the problem?
Because that would violate the principle of controlled, predictable behavior. That's at the heart of the Agentforce trust layer.
Oh,
The agent does not generate a generic error message, and it doesn't try to rephrase things on the fly. It uses a defined, canned message that's tied to the specific agent action type. For example, if it's a data retrieval failure, the message might be, "I couldn't locate that specific record. Please try again later." This ensures brand consistency, safety, and prevents the AI from improvising, which could just confuse or mislead the customer.
shifting gears a bit, let's move into Section 2, building agent actions and defining intent. We've established that the instruction is the agent's internal rulebook. So how do we make that rulebook smarter and more reliable during development?
When you're building or refining custom actions, the single most effective best practice for boosting recognition and accuracy is to include example user messages. This is an absolute must for any robust design.
So we're not just writing the instructions for the AI, we're actually giving it real-world examples of how users phrase things.
Precisely. You're essentially teaching the model by demonstration. By including diverse examples like, "I want to cancel my booking," or "How do I terminate my subscription?" or even, "Can I stop my purchase?" You're explicitly helping the model learn the context.
And that helps it map different phrasings to the same action.
Exactly. It dramatically improves intent recognition and accuracy, and it cuts down on those annoying false triggers we were just talking about.
When we define a custom agent action, there are several components we configure. Let's get the hierarchy straight. What are the core components of a custom agent action, and which one is the undisputed primary driver of execution?
So you have a few key pieces. There are the instructions, output types, and action triggers. But the instructions are, without a doubt, the undisputed primary driver of the execution logic.
And why are output types and action triggers considered secondary? I mean, they're mandatory fields.
They are, but they're secondary in terms of guiding the LLM's internal decision-making during a conversation. Action triggers define when an action can be invoked, like the user must be authenticated. And output types define the expected format of the results, like a text summary or list of records.
But the reasoning engine.
The reasoning engine uses the instructions to figure out the suitability and intent match in that specific conversational turn. If the instructions are poor, the execution will fail, no matter how well you've defined the output type.
Got it. Let's talk about a crucial standard action, the query record standard action. When should a specialist reach for this specific tool instead of, say, a simpler get record or a more complex flow?
The query record standard action is used specifically to fetch multiple records that match specified criteria. Its purpose is bulk retrieval based on filters.
Can you give me a scenario where query records is really the only appropriate choice?
Absolutely. Imagine a user asks, show me all active service contracts for customers in the West region that expire within the next 90 days.
Okay, that's pretty specific.
Very. The agent needs to retrieve a list of records, not just one and not just general knowledge. Query records lets the specialist define those filtering conditions efficiently. Region West and status, active and expiration date today, plus 90 days, and it returns that list of records for the agent to work with. It's essential for that kind of structured, multi-condition filtering.
Before we deploy any of this, of course, we need a safe space to test and refine it. What environment is specifically designated for testing and contextualizing actions before they go live?
That would be the Agent Builder functionality. Agent Builder is that designated, highly controlled environment. Its main purpose is to let specialists test all sorts of user utterances, inputting different ways a user might phrase a request, and confirming that those utterances map reliably to the correct agent actions.
And this all happens before activation.
Exactly, before activation, which mitigates a ton of deployment risk.
And within Agent Builder, how does a specialist define the scope, the context of what the agent should be able to handle?
Through topic assignment. Actions get assigned to topics right there in Agent Builder. That linkage is what defines the entire conversational map and sets the boundaries.
So you're building a structure.
Yes. For instance, assigning a create case action to the technical support topic ensures the agent only offers that ability when the conversation is contextually appropriate. That structural assignment is just fundamental to the agent's behavior.
Okay, let's pivot to a specific deployment scenario, a common exam focus. Deploying a service agent for an experienced cloud partner portal. This agent needs to do two things: answer product questions and submit new sales leads. Can the standard Agentforce service agent handle both?
Yes, it's perfectly suited for that kind of composite role.
And how does that work?
It uses its grounding capabilities to interact with knowledge articles for the product specification questions. And then at the same time, it can use flows or custom actions that integrate with standard CRM objects to handle the lead submission part.
And since it's a partner portal, security is paramount. How do we make sure only authorized users can use these powerful functions?
Access management is absolutely critical here. In this scenario, access must be restricted to authenticated portal users. This ensures that the agent's advanced capabilities, especially data creation like submitting a lead, are only available to verified partners. It maintains data integrity and security within that Experience Cloud environment.
That moves us logically to Section 3, grounding the AI data retrieval and sources. This is the heart of reliable generative AI, right? Making sure the agent doesn't just make things up.
Exactly. Grounding is the trust layer. If grounding is unreliable, the whole agent fails its mission.
So let's look at the data library and source management. A common scenario is needing to index thousands of PDF user guides. As a specialist who's focused on speed and minimal code, how do we get those PDFs ingested directly?
The primary out-of-the-box solution is using the Agentforce data library file source. This functionality is designed specifically to allow direct PDF uploads without needing any custom code or complex ETL steps.
And what happens automatically once those PDFs are uploaded into the file source? What does the system do for you?
The system automatically does two essential things. It builds a search index over the content, and it configures the necessary retrievers. This makes the PDF content immediately accessible and searchable for grounding. It basically handles all the prep work.
Now, here's a critical architectural constraint that I know comes up on the exam. If a specialist sets up a data library to point at a specific knowledge base, and later they need to change it, say point it to a different source system, can they just edit that source?
No,
Yeah.
absolutely not. That selection is permanent.
Permanent.
The data source selection for a data library is immutable. That's to ensure consistency and prevent, accidental data contamination. If a specialist needs to change the underlying source, they have to create a new Agentforce data library.
Yeah.
You cannot modify the source of an existing deployed library.
That's a huge distinction. It really emphasizes the need for careful architectural planning up
It
front.
does.
Now let's look at how the data is actually pulled. Can you contrast the two primary retrieval strategies? Default retrievers versus individual retrievers.
Sure. Default retrievers are your starting point. They're basic, out of the box, and usually limited to pulling content from a single, uncustomized source. They work fine for simple grounding tasks, but they lack control.
So when do we need to abandon the default and put in the extra work to create an individual retriever?
You use individual retrievers when you need fine-grained control. This level of customization is necessary when you have to ensure the AI only sees very specific, highly targeted information.
And how does that control manifest? What can you actually do?
It comes down to three main things: selecting specific fields to include in the results, applying complex filters to limit which records are retrieved, and controlling the maximum number of results returned.
Why is controlling the number of results so important?
It's all about token limits. If a default retriever pulls back 50 irrelevant records, that data just floods the prompt's context window. It could push out the actual relevant information or even hit the LLM's token limit and cause it to truncate.
So individual retrievers are about precision.
Exactly. They ensure the agent receives precisely the data it needs. Nothing more, nothing less, which improves both relevance and prompt efficiency.
Let's talk advanced search. We know users don't use precise corporate language. If a customer is looking for info on the Platinum Shield warranty, but they type Platinum Shield warranty, or call it the top-tier coverage, how does the system find the right document?
That's a classic problem that traditional keyword search just can't handle. The solution is vector search.
Okay.
Vector search fundamentally changes how matching works. It relies on semantic embeddings to match the meaning of the query, not the exact text strings.
So the system understands that top-tier coverage is semantically close to the vector for Platinum Shield warranty.
You got it. It identifies the intended meaning regardless of the precise wording, which makes it essential for handling natural language queries, especially with product names, jargon, or common customer misspellings.
But sometimes we need that flexibility of vector search combined with the absolute rigidity of a filter. We need deterministic results. For example, finding all open cases for a user, but we absolutely must exclude any cases marked as closed. How do we ensure that filter is applied reliably?
That requires implementing hybrid search with pre-filters. Hybrid search combines the semantic flexibility with keyword precision. And the pre-filter is the crucial piece here. It enforces that deterministic condition, for example, case status not NM, closed, pending review, at the database level.
And why is it so vital to execute that filter before the LLM sees the data?
Because it guarantees deterministic results. If you just rely on the LLM to filter using instructions like ignore all closed cases, the LLM might probabilistically miss one. It's not a database. By using a pre-filter, you avoid that probabilistic filtering and guarantee only the data that strictly meets the criteria is ever used for grounding. It's a critical distinction for compliance and accuracy.
This leads us right to Data Cloud integration. Data Cloud is the engine for unifying customer data. If we're trying to ground our AI in complex, lengthy customer history like case summaries or long chat transcripts, what type of data model object is designed for that kind of unstructured text?
For text-heavy, unstructured data, you must use unstructured data model objects, or UDMOs.
UDMOs?
Yeah. They're distinct from standard DMOs, which are for structured transactional data. UDMOs are built specifically to handle the complexity of human language.
And what capability do UDMOs unlock for the AI agent?
They allow you to create semantic search indexes on that text data. This means the AI agent can use vector search to find similar cases or resolution patterns based on the meaning of the current problem. It's indispensable for service agents trying to leverage that deep institutional knowledge.
Now, how can Data Cloud take generalized data-like web activities and use it to enrich the AI's generated output in real time?
So Data Cloud unifies all that interaction, data web clicks, purchase history, and links it to the contact or account. Prompt Builder can then leverage that. A specialist uses related list grounding in the prompt template to dynamically pull in that enriched data, say the customer's last 5 page views, right into the prompt context.
So the agent knows this customer was just looking at the pricing page for our premium product. So my response should probably mention our financing options.
Precisely. The template gets that real-time contextual intelligence, allowing it to generate highly specific, relevant insights or next best actions. The output becomes far more actionable than just a generic response.
What if a specialist defines a new custom field in Data Cloud, let's say high-value customer segment,
Hmm.
and needs the agent to use it for grounding, but the field isn't showing up in the retriever setup?
Yeah.
What's the most likely missing step?
The search index in Data Cloud must be updated to explicitly include that new custom field. If the field is on the object but not indexed, the retriever just can't see it or access it at runtime, even if the Agentforce service agent user has full permissions. Indexing is a mandatory physical step in Data Cloud.
Our final point on grounding focuses on chunking. When we upload large, detailed knowledge articles, especially HTML ones with headings, if we use fixed-size chunking, we risk splitting a heading from its text, which breaks the context. What's the recommended chunking strategy to avoid that?
You must use section-aware chunking. This is key for structured documents. Instead of just arbitrary byte limits, this strategy breaks the content into logical sections based on HTML tags or paragraphs.
And the purpose of that is?
It's designed to preserve context within each logical section. This significantly improves retrieval accuracy because the entire context block the AI receives is internally consistent and makes sense.
Okay, moving into section 4, we're delving into the Prompt Builder Toolkit. This is the specialist's interface for translating all that complex data and instructions into useful, customized output from the LLM.
Right, this is where it all comes together.
So let's start with the different template types and their uses. If a product manager needs to generate a comprehensive, structured, detailed product description, pulling together fields like name, SKU, features, and needs it to be cohesive and follow a consistent brand voice, which template is the best fit?
They should use a record summary template. That's the best practice specifically for generating a cohesive narrative from multiple fields on a single record. It's designed for consistency, ensuring those descriptions are always accurate and follow the defined structure.
What if the goal isn't a full summary, but just to have the AI populate a single specific field on a page, like generating a quick AI risk assessment text block on a new lead?
That's the distinct function of the field generation template. It's explicitly designed for that micro task of automatically generating or suggesting values for a single field. It's what powers that little generate icon you see next to a text field.
We also have templates for communication. What does the sales email template do specifically?
The sales email template is dedicated to generating AI-powered email drafts. Its key feature is its ability to personalize content dynamically, often pulling in interaction data via grounding to tailor the draft. It's all about efficiency and reuse for sales teams.
And for longer form content like internal announcements or customer newsletters, where you're combining CRM data with natural language drafting.
Those generalized needs fall under generative text tasks, and Prompt Builder is the go-to tool for managing the templates that do this. It lets you design templates that merge structured data with that free-form text generation really effectively.
Let's talk about quality control within the prompt itself. When you're writing complex instructions for the LLM inside a template, how should you format those guidelines so the AI can clearly separate them from the main content?
This is a standard practice across most LLM interfaces. Your instructions to the AI should be surrounded with triple quotes.
Triple quotes.
Yeah. That demarcation technique separates the guidelines from the actual input content, which reduces ambiguity and just maximizes AI compliance with your rules.
Beyond just formatting, what defines a high-quality, reliable prompt? What should a specialist be focusing on during refinement?
Prompt quality is really an iterative process, and it rests on 4 pillars. First is clarity and conciseness. You have to avoid confusing directions. Second, effective grounding, making sure the data is relevant. Third, role-playing or contextual framing, like explicitly telling the AI act as a senior technical support engineer.
And the fourth?
And most importantly, iterative refinement. You have to continuously test and improve prompts based on the output you're seeing to eliminate drift or unexpected responses.
Let's discuss a harsh reality of generative AI. Grounding rules and limitations. We can pull data from all over, but the model has a hard limit. What's the specialist's biggest concern about the volume of grounding data?
The primary concern is always the token limit of the underlying LLM. The specialist has to monitor and ensure the collective size of the grounding data does not exceed this limit.
And what happens if it does?
The consequences are severe. The AI might just truncate the input data, meaning the end of the context is lost, or it could just fail to generate a complete response altogether.
And where does a specialist check these limitations?
They have to review the specific limitations right inside the prompt builder configuration environment. These limits can change depending on the model you choose, so ongoing review is crucial.
Okay, let's detail the mechanism called record snapshots grounding. When a prompt template pulls data from a record, what specific fields does it pull, and what important data cleaning function does it perform?
Record snapshots grounding uses the fields that are available on the page layout that applies to that record and the user at runtime. And a keynote for the exam, the system falls back to the underlying page layout configuration. It completely ignores dynamic forms.
It ignores dynamic forms. That's a huge gotcha.
It is. And for the cleaning function, critically, to maintain prompt quality, empty data fields without values is automatically filtered out. This stops the prompt from getting cluttered with empty placeholders and keeps the context for the LLM clean and focused.
I often see people wanting to incorporate activities, like recent calls or emails, into a prompt. Can we reliably merge complex related lists, like activities, into a prompt using standard merge fields?
No. This is a known limitation that specialists have to understand. Activities use polymorphic fields, specifically who-eyed and whatted.
Which can point to different objects.
Exactly. Because they can reference multiple object types, related lists like activities cannot be reliably merged into prompts at runtime with standard merge fields. The system just can't guarantee the context or structure.
Let's pivot to the UI experience. An admin just built a field generation template, but the preview button in Prompt Builder is grayed out. What's the immediate common couplet?
The system lacks the necessary runtime context. The admin has to select the related records, a specific account, a specific contact, whatever object instance the template is designed to act on.
Right, it needs real data to preview.
Exactly. Without providing that specific data context, the prompt engine can't do the merge field substitution or grounding, so the preview stays locked out. And that's true for both Flex and field generation templates.
Finally, what is the architectural power of Flex templates? How do they differ from a standard record summary template?
Flex templates are all about complexity. They let a prompt template accept inputs from multiple unrelated standard and custom objects directly. While a record summary template is focused on one record, a Flex template can simultaneously pull data from an opportunity, an unrelated custom project object, and a contact, and then synthesize all that complex data into a single prompt.
Okay, Section 5. This is where the rubber really meets the road. Security, permissions, and data governance. Without a strong trust foundation, none of this works.
Absolutely.
Let's start with the cornerstone of data security in this ecosystem. Zero data retention, ZDR. What are the three non-negotiable guarantees of this policy?
The ZDR policy defines the boundaries between your data and the LLM providers. It's all about trust and compliance. The three guarantees are, first, no data is used for LLM training or product improvements by the provider.
Okay, that's number one.
Second, no data is retained outside the Salesforce org after the transaction is complete. And third, the data cannot be accessed by the LLM provider or its employees.
That sets the privacy boundary. On the business side, managing AI means tracking costs. How do specialists track the credit usage associated with all this AI activity?
That visibility comes from the digital wallet. Its function is to track and display credit usage associated with testing, running agents, everything. Critically, it helps you monitor costs, and it provides granular breakdowns by agent, session, or feature, which lets leadership attribute resource use accurately.
Moving to the exam killer, permissions. When a service agent is deployed, Salesforce provisions a special system user. What's the standard permission set group associated with that user?
The system provisions the user with the Agentforce Service Agent User Piece G. That's the Agentforce Service Agent User Permission Set group.
So if a specialist needs to grant this agent access to a new custom object or field, what's the best practice? Do they create a whole new permission set for it?
No. The best practice is to extend access within this existing permission set group. The specialist should add the necessary permissions to one of the permission sets inside that central Agentforce Service Agent User PIS. This keeps all the agent's permissions managed centrally.
Let's talk grounding again. If the Agentforce Service Agent user needs to access knowledge article data that's been indexed via Data Cloud, what specific permission set is absolutely mandatory for that user?
They must be assigned the Data Cloud user permission set. That permission grants the necessary runtime access to query the data cloud structure, allowing the agent to retrieve the grounded articles at the moment of generation.
Now, let's clarify user permissions for interaction. We have the prompt template user, PTU permission set. What exactly does PTU do?
The PTU permission set is designed purely for consumption. It lets standard users run and interact with existing prompts. It's the permission that makes the generative AI field icon actually appear on the Lightning page.
But it doesn't let them edit anything.
Exactly. It explicitly does not grant permissions to create, edit, or manage templates. That capability requires a different administrative permission set.
So, if an end user has the field generation template linked to a page layout, but can't see the generate icon, the first thing the specialist should check is their assignment to the prompt template user permission set.
That's it. That is the critical unlock for the consumption UI.
And if the agent needs to access a brand new internal process, say a custom product replacement object, what's the minimal access required?
Granting simple read access via an appropriate permission set is what's required for the agent to access that new custom object. And again, that access should be layered into the Agentforce Service Agent user PC.
Let's discuss a crucial security consideration about custom actions invoking flows. When a custom agent action triggers a flow, in what security context does Agentforce execute that flow?
By default, Agentforce executes the flow in system mode.
And this is a huge exam point with profound implications. Why?
Because running in system mode means the flow executes with elevated permissions. This bypasses two critical security mechanisms: the running user's field level security, FLS, and their sharing rules.
Wow, so it can see and do things the user can't.
Correct. This architectural choice ensures the automated agent action can reliably access or update necessary data, like a real-time order status that might be restricted by FLS for a guest user, regardless of who initiated the chat. It guarantees reliable business process execution.
So as a specialist, I have to be hyper-aware that any flow triggered by an agent action is running with system-level access.
Precisely. That elevates the responsibility for security reviews on those specific flows significantly.
Our final security point: model integration. If a large company wants to securely integrate a fine-tuned LLM, maybe one they trained in-house, what is the most secure and compliant method supported by Salesforce?
The dedicated, most secure method is using the Einstein Studio Model Builder. This platform lets you securely integrate and manage those fine-tuned models within the Salesforce environment, maintaining all the ZDR principles and compliance. It is exponentially more secure than workarounds like embedding models in an iframe or making unprotected callouts to public OpenAI APIs.
We've established the architecture and security. So Section 6 covers the practical details: the implementation checklist, testing caveats, and monitoring steps that guarantee a successful deployment.
Right, the final mile.
Let's start with a common deployment trap related to flows. A specialist builds a powerful flow, links it perfectly, deploys everything via a change set to production, and the agent action immediately fails. What's the likely cause?
The failure point is almost always the activation status. Flows deployed via change sets are not automatically activated in production. So any attempt to invoke that flow will hit an inactive process and fail. The specialist has to go into Flow Builder in production and manually activate it after deployment. It's a simple step, but so often forgotten.
If that flow successfully gets data, and we need to pass that structured info into a prompt builder flex template, what specific flow element facilitates that transfer?
You use the add prompt instructions element within the flow. This element is designed to format the dynamic data collected in the flow variables, record collections, whatever, and pass it coherently into the prompt builder template.
Now, connecting back to data cloud automation, if we want to kick off a process whenever a record is created or updated in a unified object within Data Cloud, what's the primary architecturally sound trigger for that?
The primary mechanism is a Data Cloud triggered flow. That is the designated flow type designed to react specifically to changes in unified objects within Data Cloud.
Let's issue a stern testing and production warning. We talked about Agent Builder, but what is the inherent high-stakes risk of running tests in the Agentforce Testing Center?
The primary risk is that the Agentforce Testing Center uses real production data.
Right.
Therefore, running tests carries the risk of modifying CRM data, creating, updating, or even deleting real records. Specialists have to be incredibly careful. Their testing procedures are isolated and non-destructive.
I can just imagine the frantic phone call. Wait, did our AI agent just delete half of our development accounts because someone ran a test?
It happens. Caution is paramount.
Let's detail the work summary configuration. To enable work summaries for enhanced messaging, the feature that uses AI to summarize conversations. What are the 3 necessary configuration steps that need to be deployed?
Okay, these 3 steps are deployable via change sets. First, you have to create the necessary custom fields, issue resolution, summary, on the messaging session object. Second, you create a quick action to trigger the generation and update those fields. And third, critically, you add the wrap-up component to the messaging session record page layout so the human agent can see and interact with the summary.
And what data sources does the work summary feature ground its generation in?
It grounds itself using 3 types of context: the full conversation transcript, any relevant knowledge articles that were consulted, and the associated case details. This makes the summary accurate and comprehensive.
Turning to AI for service prerequisites. If a company has a massive library of internal product guides and they want generative AI to answer customer questions using that material, what is the absolute first step?
The content must first be published as knowledge articles. This is essential. The grounding mechanisms rely on the secure indexing and searchability provided by the knowledge framework. If it's just raw documents on a server somewhere, the agent can't securely and reliably access it.
We have 2 related but distinct Einstein service features for human agents. Can you differentiate Einstein service replies for email and Einstein reply recommendations?
Sure. Einstein Service Replies for email is for asynchronous communication. It provides personalized, knowledge-grounded, AI-generated draft responses for incoming emails, reducing agent handling time. Einstein Reply Recommendations, on the other hand, is real-time. It analyzes live chat conversations and suggests knowledge-based grounded responses directly to the agent mid-conversation.
Once everything is deployed, where does a specialist find the crucial metrics on performance, usage, and adoption?
All of that is housed within Agentforce Analytics. That's the platform with the dashboards and reports you need to monitor efficiency, identify bottlenecks, and drive continuous refinement.
If a customer starts a chat on a digital experience site, those messages don't go directly to the agent. What required mechanism handles the routing before the message gets to the Agentforce agent?
They must be routed through omni-channel flows. These flows act as the necessary intermediate connection. They handle the intake, perform enrichment, like pulling pre-chat variables, and then route the conversation to the correct queue, whether that's a human agent or the AI agent.
Let's revisit the field generation template activation. We've created the template, assigned the PTU permission set, the template is active. But the generate icon still doesn't appear next to the target field. What final, often missed step is required?
The specialist has to edit the Lightning page layout and explicitly associate the target field, say AI analysis, with the specific prompt template. Without that manual association on the page layout itself, the system doesn't know which template goes with that field, so the generate icon stays hidden.
For a company looking to boost sales effectiveness, what's the key rationale for choosing to fine-tune Einstein with the company's own CRM data?
Fine-tuning is done to make sure the LLM understands the company's unique business context: internal terminology, product codes, specific sales language, non-standard processes. This leads to highly relevant and accurate sales responses tailored to that organization, which an off-the-shelf model could never provide.
And finally, a quick distinction on predictive AI. If an organization is running models to identify users who are likely to stop using their product, what specific prediction tech is that?
That is specifically customer churn prediction. It identifies customers at high risk of canceling, which is distinct from predicting future purchases or product recommendations.
We have completed our hyper-detailed deep dive, covering the 65 most critical, nuanced, and frequently missed subjects for the Agentforce Specialist exam. We've gone from the dynamic nature of MCT architecture and the subtle requirements of the classification description,
All the way through the necessary separation of UDMOs for unstructured data and into the absolute requirement of the Data Cloud user permissions set.
The key takeaway really seems to be the interconnectedness of all these components. Your job as a specialist is to manage these complex dependencies.
It is.
For example, knowing that if you fail to update the search index in Data Cloud, your individual retriever will fail to ground your Flex template prompt, even if the action instructions were perfect.
Or understanding that the difference between success and failure in deployment might just be remembering to manually activate a flow that was pushed through a change set. Mastering these caveats is the true key to certification success.
It truly is. And as a final provocative thought for you to carry forward, since the Agentforce service agent runs in system mode, when invoking a flow bypassing standard field-level security and sharing rules, consider the ethical and security implications.
That's a big one.
When you design a flow that automatically updates a customer record using this system privilege, How does that responsibility change your design process and your mandatory security reviews? You are designing an automated user with elevated access.
Think of the trust layer not just as a compliance feature, but as a deep governance responsibility every single time you configure system mode execution.
A perfect place to leave off, highlighting the gravity of the specialist role. We hope this accelerated deep synthesis has given you the confidence and the specific facts you need to pass that certification with flying colors. Good luck, and thank you for taking the deep dive with us.